Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's compute the antiderivative of this given polynomial function. Now, before we complicate things and introduce other rules, there are of course other techniques that we can apply, especially for this function, to make it easier. We are given here with the integral of y cubed times 2y squared minus a 3y with respect to y. Of course, it's possible to be solved because we have here with respect to y. Now, some of us might think of some rules that we might encounter later on. I'm gonna start saying it here. Let's say, for example, integration by parts. But you don't necessarily need that here, because what you can do is simply multiply this or get the simplified form of that function to make it easier, because we don't have yet the rule for multiplication, which again may be using integration by parts. But this time here, when we try to multiply that, we can just simply invoke the first three rules, specifically the sum and difference, and then the power rule and constant multiple if possible. So we have here the integral, of course, 2y to the power of 5 using the loss of exponents, and you have here minus 3y to the power of 4 dy. So from this complicated, probably expression, we have here just a binomial expression, which is easier and similar to the previous examples. Take note that we are adding exponents here and that because we have applied the multiplication law of exponents. So from this time, let's now use the sum and difference rule by separating them into two different terms. You have 2y to the power of 5 dy and minus, because that's subtraction, the integral of 3y to the power of 4 dy. Okay, now let's use the next rule, the constant multiple rule, taking out that constant integral of y to the power of 5 dy minus 3 integral of y to the power of 4 dy. Okay, so again, earlier it may look like complicated example and some of us might think of other rules. It's just basically sum and difference rule and the first two rules as well. So with that, now we have established what you call exponentiation, and we know that there is a certain power rule which allows us to do this once our n is of course not equal to -1. This is just equal to x to the power of n plus 1 over n plus 1. Then we have our c. Okay, so with this we will have 2, then you have y to the power of 5 plus 1 over 5 plus 1. Let's have c later on, because c represents arbitrary constants that is actually for the entire expression. So if you have c for this and c for that, even with the multiples, we can just simply invoke the arbitrary constant c to generalize all of those. So you have your minus 3 y to the power of 4 plus 1 over 4 plus 1. Then we have here plus c. Okay, so continuing that here, this is just equal to 2y to the power of 6 over 6, because that's 5 plus 1, minus 3 y to the power of 5 over 5 plus c. We can simplify this, having 3 in the denominator. Therefore, our final answer is 1/3. I'm removing the entire expression of a fraction, y to the power of 6. Then you have here minus 3/5 y to the power of 5 plus c. Okay, now one thing I could caution you here is, of course, when you try to check this or review whether your answer is correct or not, you can take the derivative of that, and if it's this result here, then probably your process is correct. But one thing I would caution you is that make sure that from this step to that, your expressions are also equivalent, because if in the first place these are not equivalent, regardless of whether this result would return to that, automatically your answer is correct, because in the first place, the first two steps are not equivalent. So that is the result for this expression. It may look like multiplication, but when you apply the product of your functions before you integrate them or find the antiderivative, it's just as simple as this form. Thank you very much for watching. So what are you waiting for? Subscribe now!